In this problem, we're trying to get a motor that goes at a fixed speed with a torque relationship here. So if we see here, let's first of all figure out what our torque needs to be. So the torque is going to be equal to 0.002 times 870 times 2 pi over 60 to convert it into radians squared. So let's see what that is. So we want a torque equal to 0.002 times 870 times 2 times pi divided by 60 squared. So 16.6 Newton meters. So you see here we have a fixed torque and a fixed speed, which means that we're going to have to adjust the terminal voltage to get the right torque and speed relationship. So this time we're going to be adjusting the voltage. So first of all, let's start by calculating what our slip is since we have a fixed speed. Now you see we have an 8-pole system here. So that means that our synchronous speed is going to be equal to 60 hertz times 60 to convert it into revolutions per minute divided by 8 over 2. So this is 3,600 divided by 4. Which is 900. So our slip is going to be equal to 900 minus the 870 over the 900. So we have a slip of 0.033. Okay, so let's draw our equivalent circuit. So we have an applied voltage, 0.5, and a leakage inductance of J 0.6, magnetizing inductance of 28.5, leakage inductance of J 0.83, and a rotor resistance of 0.45 divided by 0.033. Okay, so now we are trying to adjust our VA in order to get the right resistance. Well, let's break that resistor up into the two pieces. So we're going to go 0.45 divided by S minus 0.45. So 13.05. Okay, and we are trying to get a specific power in the 13.5. So our mechanical power is going to be equal to 16.6 times 870. Convert this into radians per second. 2 pi over 60. So this is equal to 16.6 times 870 times 2 times pi divided by 60, which is equal to 1.51 kilowatts. Okay, so this time we're going to solve for our power using a different way than node voltage. So in this case, what we're going to do is we're going to be using a voltage divider to get the current. So we're going to be collapsing our impedances down and then expanding back out. So what we have is we basically have VA, and we're just going to call this Z of the stator. And we're going to call this, we're just going to leave this as J25, and then this is Z of the rotor. So we see that the Z of the stator is equal to Z.5, 0.5 plus J 0.6. Z of the rotor is equal to 13.5 plus J 0.83. And then we're going to call this impedance looking in here Z2. So Z2 is going to be equal to 1 over ZR plus 1 over J 28.5 minus 1. And then what we're going to do is we're going to say that V1 is equal to a voltage divider times VA. And our voltage divider is going to be equal to Z2 over Z2 plus Z stator. Okay, and then our IL is going to be equal to our voltage divider divided by our ZR times our VA. And then our power is going to be 3 because of our 3 phases times IL magnitude squared times our 13 right here, 0.05. Okay, and then we can see, oops, and then this is going to be times our voltage divider divided by ZR magnitude squared times VA times 13.05. And then we just solve squared because our IL is squared. And then we can just solve for our VA. So our VA is going to be equal to our desired PM divided by 3 VD over ZR magnitude squared times 13.05, and then we just square root the whole thing. Okay, so let's go over to MATLAB to just plug all of these things in. So we have our ZR equals 13.5 plus J times 0.83. We have the Z of our stator is equal to 0.5 plus J times 0.6. We have Z2 is equal to 1 over ZR plus 1 divided by J times 28.5. Inverted. Okay, and then you see right here we're trying to find our voltage divider right here. Voltage divider is equal to Z2 divided by Z2 plus ZS. Okay, and then we're trying to get this portion of our IL. So we're going to go IL equals our voltage divider divided by ZR. Okay. And then we are trying to get this big equation right here. So we need our PM. PM is equal to 0.002 times our speed, 870. Convert that into radians per second. And then we're taking our torque, which is squared, times our speed. So that becomes cubed to get power. And there is our 1.51 kilowatts. And then our VA is equal to the square root PM divided by 3 times ABS of VD divided by ZR squared times 13.05, which is and then our actual stuff is in terms of line-to-line voltages. So V line to line is equal to VA times the square root of 3. So 154.5. So our V line to line is 154.5. VRMS, and then we are done. That is our answer.